From the tiny little motor vibrating your smartphone to the massive roaring turbines powering your entire city, absolutely every electrical machine out there belongs to one single, highly structured family tree. Welcome to this explainer. Today we are going to trace their genetic blueprint. We're going to methodically break down the complex family tree of electrical machines, and we're doing it purely by tracing their structural classification. If you've ever felt totally overwhelmed by all the different types of motors and generators, well, this structured breakdown is exactly what you need to see how the whole puzzle fits together.
Okay, let's dive into the master map. This gives us a complete bird's-eye view of how every machine in this category stems from one single root. From that one starting block at the very top, everything flows downward to form these distinct, highly specialized branches. And trust me, by the time we finish today, you're going to be able to navigate this entire map with your eyes closed.
Here is our agenda for the taxonomy tour. We're hitting 6 stops. The Great AC/DC Divide, decoding DC machines, exploring AC machines, synchronous versus asynchronous, the phase variations, and finally, the complete machine taxonomy.
Let's jump into Part 1, the Great AC/DC Divide, the primary split. So, right off the bat, the fundamental category of electrical machines immediately fractures into 2 distinct worlds: direct current, or DC, and alternating current, or AC. This is the foundational fork in the road. It literally dictates everything, from how the machine is powered to what specific applications it can handle. Before we can know anything else about an electrical machine, we have to figure out which side of this divide it lives on.
Moving on to Part 2, decoding DC machines, the left branch.
If we cruise down the DC branch from its parent, we hit a remarkably simple binary classification. It's just DC generators on one side, which convert mechanical energy into electrical power, and DC motors on the other, which do the exact reverse, by turning electrical power into mechanical rotation.
And honestly, this is the brilliant simplicity of the DC taxonomy. There are no complex lower levels. Once you know it's a DC machine, you really only have to ask one thing. Is it generating or is it motoring? Boom! Your classification is completely done.
Part 3, exploring AC machines, the right branch.
All right, brace yourselves, because the AC branch, it's a whole different beast. It forces us to navigate multiple, much deeper layers of subcategories. Since alternating current naturally introduces frequencies and alternating magnetic fields, this side of the family tree is way larger and much more specialized. We've got several more forks in the road to navigate over here.
Which brings us to Part 4, synchronous versus asynchronous, the AC subdivisions.
So unlike DC, AC machines first divide by how they operate: synchronous and asynchronous. Think of it like this. Synchronous machines are locked in perfect, rhythmic step with the frequency of the power grid. Asynchronous machines, on the other hand, operate with a slight delay, or what's called a slip. This is an entirely unique layer of classification that simply doesn't exist on the direct current side of things.
Now, follow that synchronous path down, and we suddenly hit a familiar symmetry: generators and motors. The function perfectly mirrors what we saw on the DC side, but now it's operating under strict synchronous rules tied to the grid's frequency. But look over on the asynchronous side. The symmetry actually breaks. Here, induction machines form the sole, direct descendant from the parent node. And this is an absolutely crucial leaf, because induction machines are the rugged, reliable workhorses driving the vast majority of our industrial world today. They don't immediately split into motor and generator nodes. They just flow right into this unified classification.
Part 5, the phase variations, the lowest leaf nodes.
Okay, now we've reached the very bottom row of the AC taxonomy. And here, every single machine forces one final structural choice. Is it one phase or 3 phase? This essentially dictates the scale. You'll typically find one-phase configurations for standard, everyday household stuff, and those robust 3-phase configurations for heavy-duty, industrial power delivery. This right here is the ultimate terminal point for the AC branches.
For instance, if you trace down to a synchronous generator, you can't just stop there. You have to classify its final variant. Is it generating single-phase power, or is it pumping out robust 3-phase power?
And the exact same logic governs the synchronous motor right next door. A perfectly symmetrical split forces it into identical 1-phase or 3-phase endpoints.
Finally, If we apply this to the induction machines on the far right, it creates this really beautiful consistency. Even though its parent lineage is a bit different, the entire AC tree uniformly grounds itself in these exact same one-phase and three-phase roots across the board.
Let's actually see this deductive logic in action. Imagine a massive power plant turbine. Okay, step 1, it's an AC machine. Step 2, it's locked to the grid, so it's synchronous. Step 3, it creates power, so it's a generator. And step 4, it feeds a heavy industrial grid, making it three-phase. See that? We just traced its exact genetic makeup.
Now let's try an everyday object, like a ceiling fan. Step 1, AC machine. Step 2, asynchronous. Step 3, induction machine. Step 4, running on standard home wall power. Well, it's one phase. What starts off looking like a vast, complex map quickly just becomes an easy logical checklist.
Finally, part 6, the complete machine taxonomy, the whole forest.
Stepping back to look at the whole shebang, the structural elegance of this diagram just makes perfect sense, doesn't it? We can clearly contrast that abrupt, highly specialized DC branch on the left with the deep, varied AC branches over on the right. It's no longer just a bunch of technical words and boxes, it's a completely logical map of electrical engineering.
Looking at our final endpoints here, it's pretty clear that the AC family, with its added requirements for synchronicity and phase variations, naturally produces way more structural endpoints. Basically, the depth of the hierarchy directly dictates how versatile these machines can be.
So, you now possess the complete structural blueprint for these complex machines. I want to leave you with a challenge. Based purely on this map we just explored, which exact branch, down to the final leaf, do you think is spinning the cooling fan inside the device you're watching this on right now? Think about it, keep following the chart, and I'll see you in the next explainer.